Hi folks, my name is Peter Bickenbach and I would like to talk about SAP Leonardo today, or the question, what is SAP Leonardo? Bernd Leukert said it's a suite of services. That's true. But where does the name come from? So Leonardo da Vinci, he was a very smart guy. He was a painter, a sculptor, an architect, an engineer, and finally a philosopher. And he was a very smart guy. People said he had an IQ of more than 220, and he died almost 500 years ago. And we said, okay, Leonardo da Vinci, due to these smart facts he had, we said, okay, we call our product name also, and the product itself and the target why we are inventing this product and introduce this into the market is that we want to support our customers to roll out their digital journey in terms of the new digital IT infrastructure, the new digital processes, etc. And beside that, I would like to draw something here. Let me take this moment and draw this infinite sign here. You might have seen already. It's not really new. And here we have modus 1. We call it M1. And here we have modus 2. Call it M2. And actually here in modus 1, we have all this what we consider as a stable core. So we product name it's S4. It is Ariba, it's Fieldglass, it's Concur, it's our supply chain fleet like IBP and APO, you might know. So this is M1. And this represents also the setup here. You see here, there is a stone, a rigid stone, a stable core. And here we have little stones, and here we have sand. And as you can imagine, M1 represents the stone. So that's where our MM is, our SD, our PP, our financial services we have here. So all this is here. We have this, and we can take the information out of here and bring them over to M2. And M2, what is M2? Those are finally the services. So Leonardo is more or less infrastructure, technology, application, and services. And while I mentioned the services, some of the services here, as you can see, is machine learning, it's big data, it's data intelligence, it's analytics, it's IoT. And those services, you have little applications in those services, which representing those little stones here. And you have the possibility based on SAP HANA and the supply cloud platform, you have the possibility to have small parts of coding which consists out of where stones out of it. That's why I like this example. Sorry, Niels Herzberg, about your example. You have stones and the sponge, which is also a nice analogy. I am using the stone because it's made of silicone, and the little sand means you can have all kinds of design rather than having this big stone here or this rigid stone. And this is where you can form individual processes. You can intelligently connect people, business, and processes with all kinds of technology. And this is where we say, okay, we have here the business, and here we have the intelligence. And this is more or less the picture and the analogy to what's on the table here. Coming to that, I like to go a little bit throughout the services, because the services are the core beside of infrastructure, technology, and the applications. And let me begin with one of the services, which is machine learning. So machine learning is kind of an artificial intelligence-based approach where we say, okay, machines become intelligent, more intelligent, they are connected to each other, they can learn from each other, they're using certain kind of algorithms, and all this based on our infrastructure here, which is SAP HANA and which is SAP Cloud Platform. Machine learning is one of them. Another one is big data. So what is big data? We have lots of data. Due to the fact that we have connected IoT devices, we are collecting data. We have weather data. We have data of densities with temperature, pressure, and so on in our machine park. We have intelligent products which are sending data. For example, if you take Rolls-Royce, if you take an aeroplane, where the engines of this aeroplane, for example, built by Rolls-Royce, sending continuously data during the flight, and Rolls-Royce is analyzing those data. So tons of data, those are big data. And how to collect this data, and how to make smart data out of big data. And therefore, we're using data intelligence. So having certain kinds of limits which you have exceeded, thresholds, etc. And this is the next service, and data intelligence, which makes, as I said, smart data out of big data. Then we have all the analytics. So finally, you want to see how you will improve your business based out of the rigid stone. We have analytics here inside, but we build our own analytics. Just one example for this is the digital manufacturing insights, which I like to show you later a little bit in a detailed demonstration. Another one is the blockchain. So what is blockchain? Usually when you hear blockchain, you're thinking about financial, you're thinking about the darknet or whatever, like Bitcoin, transfer, buying weapons and those things. This has nothing to do with it, so we don't want to go in this business. So blockchain more or less is here to secure the financial, so to say, supply chain parallel to the physical or system-supported business. Let me give you an example. So when you buy a used car, usually you see the mileages on the tachometer of your car, and in many cases the car is 6 years old and it has only, so let's say, 50,000 kilometers or mileages on its tachometer. So that might be a fraud case. So somebody has returned this mile almost to zero, or at least to a certain amount of data. And to avoid that, car producers are working on the blockchain technology to make this safe, that you cannot return the mileage to a certain amount. That's one example. There will other come in the future. Finally, we talk about the Internet of Things, the IoT. And Internet of Things, this is something, as I mentioned with the Rolls-Royce example, to bring the physical world with all the sensors into the system world. And then analyze this data, that is big data, making smart data out of big data, using data intelligence, finally using analytics to analyze this data. So, and all this is M2, the modus 2 here, and you are very flexible in it. Yeah? To build this together with modus 1 and modus 2, and this is very important. It always works together and makes it a smart approach. So for our customer, this is really to support their digital journey into the next world of IT systems, of IT infrastructure. And control this, I mean, you have the core information here, you have a modus 2 information like all the services, and get all this information onto one screen. That's finally the analogy to a cockpit of an aeroplane. So when you're landing an Airbus A380, in the last phase of the descent, what happens there? You are using only you as a human. You see the artificial horizon, you see the elevation, you see the speed, And it's good if the gear is down and the flaps are in the final position to land this aeroplane smoothly. And therefore, you have many, many assistance systems. And this is also what Leonardo does. It gives you a lot of automatically assistance systems which are behind these services in Modus 2 here to drive your business safe and smart and give you a lot of potential to innovate. And for that, we use the bridge. So the bridge is more or less the cockpit of an aeroplane. We have here the Leonardo bridge. Call it cockpit or call it bridge. Bridge, not to think about a bridge between two landscapes, more think about a bridge of a ship, so where the captain is sitting and having all this information in visible contact and doing action out of it. And the applications then, which you can trigger, supported by the services, are, for example, connected goods. So each goods is connected, for example, containers, inside a vehicle. So then we have vehicle insights. We have connected logistics. We have our new product, which comes soon. It's logistic business networks, so that you really can connect all the physical logistical goods inside a vehicle which is connected, using in the next generation the cloud track and trace, which is also an application where you really can see how is the situation, where is the vehicle with the goods inside. And let's say, is there a good which has to be cooled? So is there a cool chain? Is it interrupted? And so on. All this information you have in real time in access. And regarding this bridge, I like to show you an example for our company, which is which we have a nice case for. It's Trenitalia. Trenitalia, it's the Italian train company. And the Italian train company is finally using our Leonardo approach here to get insights regarding their maintenance situation. And I like to show this into the system. This is our first example. Coming back later with other examples and some more explanations how we can contribute it to this nice case here. So this is our example here from the Trenitalia case. And this is what we call the Leonardo bridge. So as you can see here, we have all information in one place. Here we go and see all the messages which come preactively. So low messages, medium messages, hot messages, if there is a hot message. We get the overall pipeline utilization. So the case here is we have pipelines here because trains do not drive without electricity. So we have to produce electricity, we have to distribute electricity, and we have certain points of interest here. So here we have analytic data, pipeline system volume, today's work orders. Are there system alarms or alerts? Future work orders. So it seems to be fine. And me as a Marco here, good morning Marco, there are 4 medium messages, alarm or alert messages today, but those are medium. So I'm fine, I'm drinking a coffee and see what the day brings. And then all of a sudden, there's something going on here. I can see, oops, there is a high definition alert here. We have a drop of the overall pipeline utilization down to 75% here. We have analytic data inside here all the way down this application. We see here, let me drip this over here and see what's going on. So those are data out of the IBP, and we see, oh, we should have more gas volume, electricity volume distributed, but we have a drop here. So what to do? Okay, there is the high definition alert here, and I see right away because I'm connected to IoT devices. In this case, I have even an infrared camera here. Beside the volume stream I get from the IoT, the number of outages in the week, the throughput of the impact. I got all this information using the IoT infrastructure. And let me dive a little bit more inside. And what I can see here is, oh, the gas cooler has an issue. So the first thing, I get an assistant here on the phone, somebody who takes out or shut down these gasoline pipes here, shut down the valves that no gas can take out, because gas outage is always a risk of explosions. So when that has been done, we see what we can do. First of all, I'm taking care of this high definition pressure decrease alert. And then I go into the system and see what can I do. I have to inspect and repair this valve here. Okay, I will select this. And when I have selected this, the system in the background is creating a maintenance order. And based out of the maintenance or work order with this number, I get a personnel. So this is some individual which takes care. He has a safety part, a spare parts, a safety spare parts, brings it to the place where it is needed. And then what's interesting here, the repair assistant, he also get a 3-dimensioning model. So those are 3-dimensioning data out of where this product has been produced. So those are CAD data. And he also gets instructions, service manual, constructions and options, how to maintain this case here without using any paper. So we are completely digitalized here. So when this has been done, we are fine here. You see the analytics parts here. So the drop of pipeline utilization from 75% is rising to 83%, so that's fine. We get an indication here that we have 124 parts identified with maybe similar things of failure. And therefore, we go into the system. And what we see here right now, it's the predictive maintenance case. Because in Rome, Tivoli, Avenzano, we have high risks here. And you see maintenance costs over the cost of loss due to outages versus repair cost. You see the best time spot is here in days to change in terms of predictive maintenance, at least those 3 parts here. So we are executing work orders here as well to resolve these 3 extreme high risk items. So having that done, having the people and the places on board, then I have remaining 5 medium risks. And here we are here in the life curve here. Maintenance costs are relatively high to maintain here versus repair costs here. So that is, we have at least some days, 31 to 35 days before we go into maintenance here. So, and this it's just a brief example, having all informations on board, getting priority messages pre-delivered here, having IoT informations, making out of big data, intelligent data or smart data to use them as a predictive maintenance case. This is actually where we take action here, and this is very good, where we can support Trenitalia for their digital journey into the new generation of digital businesses. That was my first example. I would like to have another example. Before that, let me talk a little bit about a new technology which is called distributed manufacturing. So what is distributed manufacturing, by the way? It consists out of more or less 3D printing. Well, this is one big part of it. And as you know from the Industry 4.0, the third innovation in industry was bringing computers into race. And we have lots of CAD data. And now if you have designed a certain part and using this computer design data and bring them into a printer, a 3D printer. And we don't talk about printing plastic or plastic-based material. We're talking about printing real metal. And this is what we called additive manufacturing. So besides forging and other possibilities to form material, we have additive possibilities. That means you have powder, sinter powder, and a 3D printer makes real material out of it. And that means, let's use the example, you want to print spare parts somewhere in the world where you urgently use the spare parts. Then you distribute this data, which you already have out of your design phase from the product, towards a decentralized 3D printer where you print finally the spare part and then assemble the spare parts to wherever it is needed. That's distributed manufacturing, one part of it. Another thing is, which I like to show you now in the next demonstration, it's digital manufacturing insights. That means we have lots of real-time data, machine data. We're using IoT devices. We might have machine learning in place, etc. And we're using the analytics services for this and bring all this into a Fiori design-based analytic bridge or dashboard. And I would like to show you this example here. And let's go into the system here. Before that, we have to define, measure, analyze the data to get an improvement and finally a control process out of it. And I like to show this in the system as well. So next system demonstration here. Let's see what it is. What you can see here right now is this dashboard where we finally have this global manufacturing insight. Because, because I'm getting older, I have my glasses here, otherwise I cannot see anything. And let's go into here. So what we see here right now, it's different analytic data out of global manufacturing plant here. So we have South America, South Africa, Europe, and southeastern part of the world, where we have different data of our machinery park. So we have certain start times during a quarter, and for that you see here where purchase orders not have been started to produce certain material right in time due to lack of system availability. And what you can see here now, you have this data worldwide available. You detect the defect of, in this case, 140 threshold defects here. You go inside and go exactly on the machine level, where you then go into detail to analyze what finally the problem is here. So the defect count by defected categories. Some of those here are in the plant regarding a certain material, in this example, the engine 800 cc. And then the ways how to design this, it's very easy to make up this design for this analytic data here. So you design your new project here. You open the dashboard, by the way, and then you say, okay, I want to define a new threshold for a certain plant, and then I'm designing here the layout. It's very easy by drag and drop. I'm using standard KPIs here, also using drag and drop, and this is where I can easily design my own dashboards here. Now I'm selecting the plant, and in the next case I'm selecting the measure, which I finally want to measure against the threshold here, and then I design what kind of, is it a pie chart or a linear chart, a classical bar chart, and I punched it in here, and then not forget saving it, very important. And then I like to launch this here, giving a certain name here, and then finally this tile is available in my dashboard. So it's very, very easy to have distributed analytic data in my machine park, which I can use then to build up my own KPIs here. And all this is in general, as an example, called the digital manufacturing insight. So very, very interesting. Another example we have, which you already know, it's KESA. KESA is reimagining its business model. So finally, they are selling air, not compressors. They're selling air. The measure here is cubic meter. And everything around it. So finally, the customer only pays for the air. We have the BASF. BASF is also reimagining their collaboration. So they have a huge AIN, Asset Intelligent Networks, in place, which is supported very much by SAP Leonardo. We have Komplett. It's a Norwegian retail chain. So they deliver retail products, grocery products to your home base, so wherever you are. So that is very interesting. So the order point as a retailer to get this information using Hybris, for example. Having all the informations, what finally the customer wants to have, retrieving all the goods out of the warehouse, replenish the warehouse, and then driving this to all the customer sites. Also, those are more or less households. And therefore, we have also vehicle insights, we have track and trace, so the customer can finally follow up where its goods are. Another example is the Harbor Port Authority, where we can control the harbor port, because the harbor port is always an issue due to traffic, due to logistic traffic, due to regular traffic, due to the lack of space where to store, and to know how the situation is inside the harbor, what's going on, and to then recontrol or detour certain traffic, certain logistic points. This is where we support with SAP Leonardo. And of course, we have Harley-Davidson. So they are reimagining their business processes. Their issue or their challenge always is lot size 1. And lot size 1 means the customer can individually change its customized setup or customized order 6 hours ahead of production time. So this is really a good thing. Here we're using, in terms of Modus 1, we're using manufacturing execution, manufacturing insight intelligence, we're using APO, we're using, of course, ERP. So this is something where we can support our customers. Another one, a good example, is Hilti. They are reimagining their customer experience. So Hilti, when you buy a Hilti device, a really professional device, then you don't pay for the device. You pay for the usage of the device. You pay for each hole you have drilled. So finally, there are lots of devices inside the drilling machine. And when you drill the hole, then it consumes the time, it consumes the energy and the wearing of finally the drill. And this is where you pay for. And all this insight, all this IoT data are going into the Leonardo application, or Leonardo suite. And from there, finally, we make it possible that the customer gets a bill due to what finally the usage of the tool was. So this is those are some of these examples. And now let me come to the next step for the customers. What about prototyping? How can we approach here? How can we go further? And therefore, we have what we call the Leonardo accelerators. And we have two types of accelerators. We have industry accelerators and we have IoT accelerators. And those accelerators, they consist more or less out of a design thinking service where we bring our technology knowledge into the race, as well as the industrial knowledge. Of course, we have the software like the cloud, big data, and all the services. And then we bring this together, and the step is always the same. We using design thinking as a start. And from there, we do this as an exploring day. We do it within 1 day. This is what SAP finally is paying for as our investment, and then we do a design. So that's the explore phase is for 1 day, and the design phase, it's for 2 weeks. And this is what SAP's investment is about. And the next step is deliver. And the delivering time is 6 weeks. And this is where the customer has an engagement. So the customer finally has to pay for this. And the interesting thing is here, beside the IoT accelerators, we have also industry innovation accelerators. So let's, for example, for the retail industry, for the consumer products industry, for the discrete industries, we have accelerators. We have the predefined services in place. And we have a best of breed. We have a huge knowledge base here, best practices, that's what I want to say. And to bring all these services into place on all this knowledge, this accelerates a little bit. That's why we call this obviously accelerators. They cost a little bit, but in the way when the customer gets into the delivering phase, so 6 weeks, after 6 weeks the customer has to pay, and this is also good, and I think it's a fair approach. So Leonardo services for IoT and Leonardo services for the different industry packages. So, and I'd like to encourage you to go to the customers, go to your customers and do the same. So this was for me a pitch try to explain SAP Leonardo, and I'm happy to go out to the customers and to make this presentation to the customer. I'm willing to work on more proof points, and I think we are just in the beginning of this brand new phase into the new digital journey for our customers, for ourselves, and I'd like to thank you for your attention in this video, and I wish you a nice day. Again, my name is Bickenbach, and bye-bye.